Alright, g'day guys. Little year 13 calculus lesson from home. I posted on the Google Classroom that I wanted you guys to find a circle and elliptical model for some given parameters. So I wanted a model for a height of 16 meters and a width of 80 meters. So when I drew this thing, it looked pretty similar to this, right? So 80 along there and 16 up there. So just do a quick recap of the circle. The circle equation came out to be x minus a all squared plus y minus b all squared, and that was equal to radius of the circle squared. We also we know very class parametric equations. So the parametric equation was x was equal to r cosine theta and y was equal to r sine theta. If you remember, the cosine of a right angle triangle gave you this gave you your horizontal, right? It gave you your base of that right angle triangle, and this gave you the vertical height. So together they give you any position on a circle. We also have the ellipse, and that had a center at x minus x1 squared over a squared plus y minus y1 all squared over b squared, and that gave us 1. That gave us an answer of 1. Don't get confused between these a's. They're totally different, right? That's a circle centered at AB. This is an ellipse centered at x1 y1, and if you remember, these were that A is half of your major or minor axis, and that B is half of your major or minor axis, depending on the orientation of your ellipse. Here, your major axis that's 2A, and here your major axis is 2B. So just be aware of that. So what we're going to do is going to go straight into fitting this model, and we'll start with the ellipse. It's really easy. In the NCA, it's usually an achieved skill to fit the ellipse. So what we're going to do is going to center that origin there, right in the middle. And that means there's going to be no movement for the ellipse. It's just going to be x squared over a squared. Now a is half of that major axis, so 40. So that's going to be over 40 squared. And b is half of your minor axis, so half of your total cross section there. And we already have that, that's 16. So just be wary that it's not 32 and it's not 8. You've been given that minor axis straight away, or half that minor axis straight away. So that's over 16 squared, and that's equal to 1. So there you have it. You have the Cartesian equation for the ellipse pretty much handed to you in this internal. You just need to also write down your parametric equations. So parametric equations, or writing this not in with respect to 2 variables, but with respect to 1 and maybe some constants. You're going to get x is a cos theta, so 40 cosine theta, and y is going to be b 16 sine theta. And there you have it. You're pretty much at achieved. The circle is something we've done quite a bit before. We've been plotting circles through 3 random points recently, and it actually gets easier with a model like this. So if we go through the circle, we're going to go through the circle model now. Alright, the circle model. We're just going to chuck this on the Cartesian plane. Alright, so we're on the axis, and again we've got the origin there, so it's semi-centered, right? But that circle would actually go way down here, and the center of the circle would actually be down here. So we've obviously got a circle that's just dropped down. So in our circle model, our general equation is just going to be x squared, it's going to be x squared plus y minus b all squared equals r squared. So you could pause that now and just have a think about why I don't have any horizontal movement. And that's because I'm only moving that circle down. I don't actually need to solve for an a value there. So I can do this. I can just write x squared, so no horizontal movement, and just a vertical movement from the general equation. What I do now is I just set up some simultaneous equations, so I can just chuck this point in here. And hopefully you guys can see in red in the camera, but I'm going to call that, that is 16 high and 0 across it. 0, 16. I'm going to put this point into another equation as well, and that's 40, 0. I'm going to get two equations. So equation 1, I'll put 0, 16 in. So that's just going to be 0 squared, 16 minus b all squared is r squared. And equation 2, well, that's going to be with the other point. So I just put 40 for x, so 40 squared plus 0 for y. So I don't actually need brackets, but that's going to be b squared is r squared. Okay, so there's 40 in for x, 40 squared plus, and that's 0 minus b is negative b all squared. I can equate, because they're both equal to r squared, I can equate the two simultaneous equations. Says that's true. So I can go, and if I make each side equal, minus b all squared equals 40 squared plus b squared. You can see that now I'm just solving for one value, right? One variable, one constant b. So let's expand and simplify this whole thing. So 16 squared, I think, is 256 minus 32b plus b squared is equal to 1600 plus b squared. And this is the beautiful thing about using coordinates that lie on the axes. These b squareds are going to cancel, and I'm left with 256 minus 32b is 1600. So I could take, I could add 32 to one side and take away 1600. What do I get? So 256 take away 1600 is negative 1344. 1344, and that's equal to, if I add 32b to both sides, 32b. Last step is to divide by the 32. So divide by 32, and I've got negative 42 equals b. That's not bad. That is not bad at all. So let's have a look at this. So b is negative 42. I just need to figure out what my r is going to be. So I can just take this and just plug it into either of these. So I might just plug it into the second equation. So if I get 40 squared plus 42 squared, and then I square root that, well, I don't need to square root it, but r squared is actually 3364. So my circle equation is x squared plus y. Now be careful, because it's y take away b, and b was negative, so it's actually plus 42 all squared is equal to 3364. And that was really nice. Actually, didn't think I'd get whole number solutions for all of that, but 16 and 80 seem to have done the trick. The last thing is I would probably want the parametric equations. So parametric equation is, well, we have no horizontal movement, so x is just r. I do need r then in the end, don't I? Square root of 3364, 58, so r r is 58, by the way, so that is 58 cosine theta, and y has a vertical movement of 42 downwards, so negative 42 plus 58 sine theta. So that's r cos theta, and that's r sine theta from our parametric equations. But we've just got a vertical movement, so we have to subtract that. And there we have it. We have a circle equation written parametrically. We have an elliptical equation also written parametrically, and you're going to get some really good grades for being able to fit a circular model. And we're done. Give me feedback on the video, lads. It's for you guys. So if you can't read it very well, or there's other software issues like it's not rotating or something like that, I need to know ASAP so I can get onto that. Like I say, it's just going to be a 3-day trial for me, and we'll be hopefully good to go next term. Like that smash button.